Hello lovely people, welcome back to another video where we are doing a walkthrough. I will literally just be going through some questions, explaining my thoughts so that you have an understanding of some of these questions, and it will also give you an insight as to what topics from the paper one for the non-calculator, AQA, GCSE topics you do and don't know. And it will then give you an opportunity to go and find topics on that particular question to practice. Let's do the first question. So work out 3 2/3 plus 1 7/10. So if you're doing the higher tier paper, this one is pretty much a knowledge-based question. There shouldn't be too much of a problem-solving aspect. It's just knowing what to do. So I'm going to go for the approach of changing these both to improper fractions. So I do this big 3 times the denominator, times the denominator. So 3 times 3 is 9, plus 2 is 11, so that becomes 11 over 3, plus, and then 1 7/10, well, 1 times 10 is 10, plus 7 is 17, over 10. Now, I'm going to make them have the same denominator, so I'm going to times this by 10 and that by 10, times the other one by 3, times the top by 3, making them have the same denominator, and that's going to transform my question into 110 over 30 plus 51 over 30. Adding them is going to give me 161 over 30. And then to convert that back to a mixed number, how many 30s go into 161? Well, that's going to be 5. 5 times 30 is 150, so the remainder is 11. So 5 and 11 over 30. There we go. Next question is to multiply. So again, we're going to change these into improper fractions. So 1 times 3 is 3, plus 1 is 4, so it's 4/3. 2 times 5 is 10, plus 2 is 12, so that's 12 over 5. And then, multiplying these out, I get 48 over 15. I can simplify that by dividing both top and bottom by 3. 48 divided by 3 is 16. 15 divided by 3 is 5. And then how many 5s go into 16? Well, that's 3 and 1 remainder. So it's 3 1/5. So 3 1/5 right there. Next, we have 2 17ths divided by 2 5ths. So this one is already in, there are no mixed number forms to have to deal with. So here we multiply by the reciprocal. So we keep the 2 17ths as it is, change the divide to a times, and then find the reciprocal of 2 5ths, which is 5 over 2, or keep, change, flip, as some people refer it to as. And then that becomes 10 over 34. Both top and bottom can be divided by 2, so it becomes 5 over 17. And there we go. Let's keep going, guys. I'm working at a pace here. What's the reciprocal of 4? Well, 4 can be written as 4 over 1, and then it's that flipping process, so the reciprocal is 1 over 4, so that option there. Next, 0.3 times 0.3. Here's how I like to work it out as a way that we can explain why it is what it is. So 0.3 is the same thing as 3/10 times 0.3, which is again 3/10, which gives 9 over 100. 3 times 3 is 9, and 10 times 10 is 100. So that's 9 over 100. And then 9 divided by 100, converting it back to a decimal, is 0.09. Because a lot of the times people want to say 0.9 is a common wrong answer, but hopefully this explains why. Let's do the next one in a similar way. So we've got 0.06, which is 6 over 100, multiplied by 0.4, which is 4 over 10. So that gives 24 over 1,000. And what is 24 divided by 1,000? Well, it's 0.024. Okay, next one, 1.9 times 1.2. Well, 1.9 is the same thing as 19 over 10. 1.2 is the same thing as 12 over 10. So again, multiplying top and bottom, well, 10 times 10 is 100. We can do a quick multiplication of 19 times 12. So 19, 12. So we have 2 times 9, which is 18. So 8, carry the 1. 2 times 1 is 2, plus 1 is 3. We go into the 10, so we put a 0 as a placeholder. 1 times 9 is 9. 1 times 1 is 1. Add the numbers up. We get 8 plus 0 is 8. 3 plus 9 is 12, so it's 2. Carry the 1. 1 plus 1 is 2, so 228. 228 over 100. 228 divided by 100 is 2.28. So that is our final answer. Now for the division problems, this is what we do. So I like to write this as a fraction. So 1.72 divided by 0.8 can be written as 1.72 over 0.8. And we're going to multiply the top and bottom by 10 so that the bottom is a whole number. And remember, if I times the top and the bottom by the same thing, it's an equivalent fraction. So that becomes 17.2 over 8. Now we can just work out what is 17.2 divided by 8. So we do 8 into 17.2. So 8 into 1 doesn't go. 8 into 17, though, goes twice, and the remainder is 1. Remember to put the decimal point above. 8 into 12 goes in once, and the remainder is 4, so we put the 4 next to a 0. 8 into 40 goes 5 times, so the answer is 2.15. It's the same answer as what it would have been for 1.72 divided by 0.8. Next, we have 5 divided by 0.04. Using the same logic, 5 over 0.04. This time, if we times the top and bottom by 100, that makes the bottom a whole number, so that's 4. And then 5 times 100 is 500. And then we do 500 divided by 4. This one's a bit easier to do because we can just go 500, halve it, which is 250, halve it again, which is 125. So there we go. Right, next question. A bag contains yellow, red, and white sweets. Altogether, there were 300 sweets. So it says 7/12 of the sweets are red. So how many is that? Well, if we know that 7/12 of the sweets are red, that means that we know, so 7/12 of 300. So we do 300 divided by 12. So to divide by 12, we can divide by 3, then divide by 4, because 3 times 4 makes 12. So divide 300 by 3, that's 100. Divide that by 4, that's 25. And then times that by 7, 25 times 7, 25, 50, 75, 100, 125, 150, 175. So that's 175 red sweets. So that means that there are 125 yellow and white sweets together. Yellow and white together. Okay. And it tells us that there are 25 more yellow sweets than white sweets. So that means that if we take the number of white sweets and add 25, we get the number of yellow sweets. But also, we know that the white sweets plus the yellow sweets is equal to 125. Look at that. We've got a simultaneous equation. A pair of simultaneous equations, should I say. So we already know that y is the same thing as w plus 25, as it's written here. So let's use that. So I'm going to put w plus, and then I'm going to replace this y with this y here. So that becomes w plus 25 equals 125. So 2w plus 25 equals 125. So therefore 2w equals 100, w equals 50. And it asks to work out the fraction of the sweets that are white. So there are 50 white sweets out of 300. And that simplifies to, well, you can divide both by 50. That becomes 1/6. So that's the final answer. Next, simplify this. Well, index laws. With laws of indices, when you times and you've got the same base, you add the powers. So at the top, we're going to add the powers. So that's a fifth is one of the powers. And we're going to add 2/3. So again, to make the denominators the same, times by 3, times by 3, times by 5, times by 5. And then that becomes 3 over 15 plus 10 over 15. And that's going to give us 13 over 15. So that's a to the power of 13 over 15 divided by a to the power of 3 over 5. Okay, now when you divide, you take away the powers. So that becomes 13 over 15, take away 3 over 5. To make the denominators the same, we times this one by 3, that one by 3. There are other ways you can do this, but this one I'm just working out the lowest common multiple. which is 15. So that turns this question into 13 over 15. Take away 9 over 15, which is equal to, well, 13 take away 9 is 4, so that's 4 over 15. So final answer is a to the power of 4 over 15. A to the power of 4 over 15. Let's keep it moving, guys. So next, the number of visitors to some tourist attractions is shown in the table below. So they've given it to us in different ways. So 5.4 million, Castle 923,840 or 923,840, Theme Park 1.43 times 10 to the power of 7, and the Science Museum Double Comma Club 4,192,900. Write the number of visitors to the theme park as an ordinary number. So we're doing 1.43 times 10 to the power of 7. So 1.43, and then I'm going to times it by 10, 7 times essentially. So every time I times it by 10, we can kind of think about it as a decimal moving to the right, though really the numbers are moving to the left. But as Einstein once said, everything is relative. So 1, 2, 3, 4, 5, 6, 7. Decimal point moves here now. And then we fill up the gaps with zeros. So our number is 143, 0, 0, 0, 0, 0. And the decimal points at the end is just an ordinary number. So 143. And I've separated out like this, so we can see it's 14,300,000. Okay, next, write the number of visitors to the castle in standard form. Well, 9, 2, 3, 8, 0. 840. So it's going to be something times 10 to the power of something. So the first bit, the first number has to be between 1 and 10. So where would we place the decimal point so that this number is now between 1 and 10? We'd place it between the 9 and the 2. So that's 9.2384. We could put the 0, but we don't need to because it doesn't change anything. So 9.2348 times 10 to the power of, well, how many jumps to get from where the decimal point currently is to the end of the number on the right? 1, 2, 3, 4. So times 10 to the power of 4. So 9.2384 times 10 to the power of 4. How many more people visited the theme park than science? So, well, we know that the theme park number was 14,300,000. And for science, it was 4,192,900. So we're going to subtract. So 0 take away 0, 0, 0 take away 0, 0, 0 take away 9. You cannot do. You need to take 1 away. Oh, we can't take away 1 from this 0 because there's nothing to take away. So we go to the next one and we still can't do it. So we go again. And then we go to this 2, cross out, this 3, cross it out and put a 2. Then we put a 1. Now we can take 1 away. So 10, 9. Then we put 1 here, 10, 9. Then we put 1 here. 10 take away 9 is 1. Next, we move on to 9 take away 2, which is equal to 7. 9 take away 9 is equal to 0. 2 take away 1 is 1. 4 take away 4 is 0. 1 take away nothing is still 1. So our answer is 10,107,100. 10,107,100. Next question. Edward and his 4 friends go on holiday. The total cost of the holiday is £3,600. Edward is going to stay longer than his friends, and he's going to pay 35% of the total cost. Fair enough, you stay longer, you pay more. That's a fair way to do it, I guess, maybe to an extent. The rest of the total cost is to be shared equally between his 4 friends. Edward says, I pay twice as much money for the holiday than each of my friends. Is Edward correct? Well, let's find out. To be honest, we don't actually need the £3,600 to be able to work out what whether his statement is correct. And I'm going to show you how. So we could do the thing where we work out 35% of 3,600 and then take it away from 3,600 and divide by 4 and then find if that number works. But if you know that Edward pays 35%, that means that the 4 friends, so Edward pays 35%, that means that the 4 friends between them pay 65%. And then if you take 65% and divide it by 4, so 4 into 65, or 4 into 6 goes once, remainder 2. 4 into 25 goes 6 times, remainder 1. So put it next to a 0. 4 into 10 goes twice, remainder 2, and then 5. So 16.25. And he says he pays twice as much for the holiday than each of his friends. So each of his friends pays 16.25%. So each friend pays 16.25%. Well, let's take 35 and divide it by 2. Well, that's equal to 17.5. So 16.25% is not equal to 17.5%. Therefore, no, Edward is not correct. By the way, these 3 dots here in maths means therefore. So I've written that just to make it shorthand. And there we go. We didn't actually need to use this £3,600, though you could have. Next, write 1.325 as a fraction and give your answer in its simplest form. Okay, so with these kinds of questions, we say let x equal 1.325, which, by the way, I'm going to write it like this. I'm going to write it the longhand way. So 1.325, 325, 325, and so on. Now, I'm going to do 10x, and I'm just going to go through this slowly for a minute. If I do 10x, then that means I get 13.25, 325, 325, and so on. It goes on forever, right? There's an infinite number of 325s. So if I move everything to the left, numbers, then it's still going to be 25, 325. Now the problem is, though, the numbers after the decimal points don't match, because the first one starts with 3, then 25, and then 325, 325, 325. But the second one starts with 25. So I need to multiply again, giving us 132.5, 325, 325, and so on. But even still, that does not match. So if I times again by 10, I get 1,000x, giving 1325.325, 325, ... And now this matches with this, because they both have the same numbers after the decimal point in the same order, starting with 325. So it means that now things can cancel. So if I did 1,000x, take away x, that gives me 999x. If I did 1325.325, take away 1.325, then it's going to be equal to something 0.0, because everything after the decimal point cancels. 1325 take away 1 is 1324. Then, if I'm dividing, I get x is equal to 1324 over 999. Okay, now we just need to simplify that. Can that be simplified in any way? So 1324, well, 1324 is not divisible by 3. Is it divisible by 11? No. Nope, it's not divisible by 11. So yeah, it just stays as 1324 over 999. So that's our final answer. Let's keep going. Charlene and Daniel share some money in the ratio 28 to 36. We want to simplify the ratio 28 to 36. Well, these can both be divided by 4. So if I divide by 4, this becomes 7, this becomes 9. So it's 7 to 9. Okay, moving on. Danielle gets £48 more than Charlene. How much does each woman receive? Well, Danielle is 9 rather, and Charlene is 7. So that means that Danielle gets 2 more parts. So, and also we know that Danielle gets £48 more. So that means that the 2 parts must correspond to the £48. And then if you can work out 7 parts, that's Charlene. And if we work out 9 parts, that's Danielle's parts. So dividing by 2, we get 1 part. So divide that by 2, we get 24. And then to get 7 parts, we times by 7. So 24 times 7 is 168. So 168 for Charlene. And then if we times by 9, we get 9 parts. And when I say times by 9, we're timesing the 1 parts by 9. So therefore 9 parts is going to be, well, 24 times 10 is 240. Take away 24 is 216. So that's 216. 216. There we go. All right, let's keep going. So next question is C is directly proportional to the square root of y when C equals 12.8, y equals 16. So 2 aspects here. Directly proportional means C equals this constant k times something, and it says the square root of y. So C equals k times the square root of y. Cool. That's fun. Then we know that when C equals, so basically we can simplify this to C equals k root y. And we know when C equals 12.8, y is equal to 16. So k times the square root of 16. So 12.8 equals k times 4. So therefore k is equal to 12.8 divided by 4. Well, 4 into 12.8. 4 into 12 goes 3 times. Decimal point. 4 into 8 goes twice, so 3.2. But we're not done. We then write C equals k, so 3.2, multiplied by the square root of y. That's that. Then it says find C when y equals 400. So we substitute y equals 400, so we get C equals 3.2 times the square root of 400, which is equal to 3.2 times 20. So that's equal to 6.464. How did I do that so quickly? 3.2 times 2 is 6.4, and then times it by 10, 64, because we can break up 20 into 2 and 10. Another proportion question. The force F newtons exerted by a magnet on a metal object is inversely proportional to the square of the distance. So inversely proportional means this time F equals K, not times, but divided by or over the square of the distance, so d squared. Okay, and we also know that when d equals 2, F equals 50. So we have 50 is equal to K over d squared, or 2 squared. So 50 is equal to K over 4. Therefore, 200 is equal to K. So our final formula, our final expression of F in terms of d is equal to 200 over d squared. That's it. So F equals 200 over d squared. Next, find the force when the distance between the magnet and the metal object is 10. So we substitute d equals 10. So sub d equals 10. And we end up with F equals 200 over, not d squared, but 10 squared, which is equal to 200 over 100, which is equal to 2. So F is 2 newtons. And it says find the distance between the magnet and the metal object when the force is 8. So we substitute this time F for 8. So we write 8 equals 200 over d squared, which is our formula. And then what I'm going to do is multiply both sides by d squared, a bit like cross multiplication. So 8d squared is equal to 200. Then dividing both sides by 8, I get that d squared is equal to, well, half of 200 is 100. Half it again is 50. Half it again is 25. Remember, 2 times 2 times 2 is 8. So to divide by 8, you can divide by 2, then divide by 2, then divide by 2. That's what I did. And therefore, d is going to be 5. Some people might say, oh, but -5 also squares to give 25. It's a distance. Therefore, we know it's going to be positive. Oh, they put centimeters. Let me just check that everything was in centimeters. Okay, it is in centimeters. Centimeters, okay, cool. Just checking that I wasn't being tripped or tricked. Explain what happens to f when d is halved. So we know that our formula was f is equal to 200 over d squared. A good way to do this is just pick two values really of d. So suppose if d equals 10, then f equals 200 over 10 squared, which is 200 over 100, which equals 2. And then if d is halved, so d is 5 now, then f equals 200 over 5 squared, which is 200 over 25, which is equal to 8. Look what happens. It gets multiplied by 4. So when d is halved, f quadruples, or f is multiplied by 4. And that kind of makes sense because if it's inversely proportional, halving 1 or dividing by 2 would mean you times. And because it's the square, it's timesing by 2 squared. So that's it. Okay, this next question is an interesting one. 8 builders can finish a house in 20 days. Each of the builders works at the same rate. 6 of the builders stop working after 14 days. The other builders continue building the house at the same rate until it is finished. How long does it take to build the house? Wow, okay, these kind of questions. Right. So, how am I going to do this one? Okay, I'm going to say 8 builders do one house and it takes 20 days. Cool. So that works. And it says each of the builders work at the same rate, so, you know, there's no one builder working faster than the other, and I guess we assume as well that they don't get tired. Some bionic builders, but it's okay. So it says 6 of the builders stop working after 14 days. So essentially, we need to work out how much of a house is built after 14 days and how much of that house is left. So if I divide everything by 20, not everything, if I still have 8 builders, but divide the other 2 by 20, if I divide the number of days by 20, so it gives just 1 day, then we expect to build less of a house, namely 1/20th of a house. Right? That makes sense. Then, if we have 14 days, we times by 14, so that's 14/20ths of a house, and that's still the 8 builders. Okay? So that means that after 14 days, we build 14/20ths of a house. That means that we have 6, and that's taken 14 days, and we have 6/20ths of a house left to build. Okay, and then it says 6 of the builders stop working, so now we only have 2 builders left. So if I take this first equation, or this first relationship, and say 2 builders, we've now divided the builders by 4, so we can think about it in 2 ways. Either it would take 4 times the time to build one house, or we'll build just a quarter of a house in 20 days. I'm going to do it by considering the quarter of a house. So 2 builders will build a quarter of a house in 20 days. Okay, and now we need to work out how long it's going to take them to build 6/20ths of a house. So first of all, note that this 2 builders A quarter is the same thing as if I times the top and bottom by 5, I get 5 over 20. So that's 5/20ths of a house. That's still going to be 20 days. If I divide by 5 for the house bit, then the two builders will build a 20th of a house in 20 divided by 5 is 4, so 4 days. Then if I times by 6 for the number of houses, so there's two builders will take 6/20ths, will build 6/20ths of a house, and that will be in 4 times 6 is 24 days. So it takes two builders to build the remaining 6/20ths of the house in 24 days. So in total, we have 14 days plus the 24 days, giving us 38 days. So hopefully that logic there makes sense. Right, we'll leave it for this video and we'll continue with question 15 in the next video. Take care for now.